Welcome to all. This is lecture number 2 for centroid and moment of inertia. Right now we are in the centroid. See, what is centroid and also what is center of gravity? Actually, so many times we take both same, but still technically center of gravity is the first center of gravity. Center of gravity means, briefly I will tell you, see, first center of gravity briefly, where weight considered, and then we will go to centroid, where area considered or lamina considered. 1 minute. See, consider a three-dimensional object. Three-dimensional, not two-dimensional. See, any random three-dimensional. For example, see, same thing, I will take this way. Yesterday used for experiment. See, to understand what is center of gravity and centroid, you go through the previous class number 1 introduction class. See, here, how the way I hang it here, weight will act like this. In case I hang somewhere from here, weight will act like this. Suppose I put a thread here and hang, weight will act like this. In all the 3 cases, or not 3 cases, any number of cases, the line of action of the total weight will pass through one common point, that is through which the resultant is either total weight or resultant of all the, you can call resultant also, resultant weight will pass, is called center of gravity. So center of gravity is 3D, where weight considered. See here, where you consider x, y and z. See, for example, x, y and z. Okay, now time being, leave it. Come to centroid. Centroid is for 2D. See here, where area or lamina considered. And in structural engineering, most important, in structural engineering, it is for cross section. Actually, entire, see, you can write here, entire structural engineering, the most powerful term or the purpose of every design engineer is to decide cross section. That's all. Reasons all I will tell in the respective structural class, not here. That is cross section. Cross section means what? It is a plane area. See, here x and y. See, z is not there. So this is center of gravity and centroid first, briefly. Now, you come to first, how to locate center of gravity first. I'll first tell how to locate center of gravity. I won't rub too much actually. Okay. How to locate center of gravity. See. Now what we will do is, for easy understanding, we consider a block, what we can call is some body where thickness is constant. Very important. See, now you imagine some body here. See, this is x plane, this is y plane, this is z plane. The thickness of this one, see, you imagine thickness is T. Thickness equal to T. Actually, uniform thickness. The purpose is that I am telling for understanding. Later, when you go to lamina, thickness will not come, or it is understood that it is uniform thickness. Okay, see here. Now, to understand correctly, this you divide into multiple number of parts. Anyway, either this vertically, see, divide into parts. Multiple number of parts, etc. Here, that way. See, part 1, part 2, part 3, part 4, sufficient, etc. Part n. How many parts we are not knowing? Now, let weight of each part, see, weight is acting vertically down, somewhere here, W1. Let this weight, part 2, be W2. Same way, this weight is vertically down, W3. Actually 1, 2, 3 sufficient, etc. This weight is Wn. Now, you take any reference axis here. See, x, y, I will tell later. It is any reference axis. Any reference axis. To locate or axis considered for horizontal distance. Horizontal distance. Now, one very important, you should know that much basic knowledge. Whenever you want a horizontal distance, reference is always a vertical line. See, from a vertical line, you always consider horizontal distance or x. Same way, from a horizontal line, you always consider vertical distance y. This you should know it. See, suppose I move in this room this way. I should tell from a vertical wall here. See, I am moving with respect to a vertical wall, horizontally how much I am moving. Or if I lift something here, if I move this way, I am moving vertically from ground. So remember now, from up to end of structural engineering, for any horizontal distance, reference axis is vertical. For any vertical distance, reference axis horizontal. I will write once again here. Very, very powerful. For note, last time I will tell. For any horizontal distance, reference is a vertical axis. And see any horizontal distance, see here, and for any vertical distance, reference is a horizontal axis. See, this way. Once again, any horizontal distance is from a vertical axis or vertical line. Any vertical distance is from horizontal. Now, you take any reference axis. This is for horizontal distance. See, let it be x1. See, we will do one thing. We will measure x like this. X. This is, let it be x2. Let it be x3. Same way, let the last one be xn. Now, in the same body, what you do is, let this is center of gravity G. Actually, it is inside the body. If it is inside body, you project here G, where weight of the entire body is acting. W. See, W1 is for part 1, W2 is for part 2, W3 is for part 3. That way, Wn is for part n, W is for entire weight. Now, for this part 1, let this area, see area here in the plane, let the area equal to A1. For this one, let the area equal to A2. For this one, let the area equal to A3. For this one, let area equal to An. And for entire here area, let area equal to A. Let area equal to A. 1 minute. Let's check the camera. Sometimes problem comes because it goes out of camera. Oh, okay, no problem. Let area equal to A. Now, one more thing required. I will remove this one now. Area equal to A. Now see, let T be the thickness. You cannot see here. See, thickness is this way. Now, we know that weight equal to volume into weight density. You should know from physics. weight density. Let it be rho, some symbol. Some people use, okay, W, weight density, W I will tell, W, okay, instead of rho, W. See, for example, kilonewton per meter cube. Suppose you take 1 meter cube of water, it will weigh 1000 kilograms or 10 kilonewton, that way. Weight density. That is weight. Weight density means weight per unit volume. Unit volume. Okay, weight is equal to volume. Therefore, weight W1 equal to, and also you know that volume equal to area into thickness. Area into thickness. Area into thickness. This everybody knows. Volume equal to area into thickness. So, W1 equal to area is A1, thickness is T into W. This is constant for a material. See, this is constant for a material. Constant for a material. So, same way, W2 equal to A2 into T into W. Same way, W3 equal to A3 into T into W, etc., etc. Wn equal to An into T into W, and capital W, entire weight, I will put capital, red color, capital W equal to full area, that is A, full area A into T. See, that area will be capital A here, red color. Later I will change the color. A into T into W. Undoubtedly, your capital A equal to A1 plus A2 plus A3, etc. up to AN. Okay, sufficient. Now, what to do is, I will remove this axis now. See, I want some space actually. We have to write here. Now some space problem is there. Okay, I will write some more manage here. Okay, now you apply Varigno's theorem. Varigno's theorem. Before that, you do one thing. Let W, that is, already told. See, resultant load W will pass through centroid of the centroid or center of gravity. Let x bar, see, this is for part 1 x1, for part 2 x2, part 3 x3, part n xn. For everything, no x1, x2, x bar be distance of CG, distance of centroid G, center of gravity G, from same reference axis. Very important. See, this is the reference axis. Reference axis. From, very important, same reference axis. In the same direction as x. In same direction as x. That is, see here, this will be your x bar. See, if you mark x1 this way, x2 this way, x3 this way, xn this way, x bar also is marked like this, x bar. Now, apply Varigno's theorem. I will use statement for you. Algebraic sum of moment. See, this is actually is a parallel force system. You should write first of all. This is W1, W2, W3, etc. up to Wn. That is individual weights. They all are acting vertically down. So they will form a parallel force system. So dynamic action of resultant will also be vertical. Wait. Now, Varigno's theorem. Algebraic sum of moment of all the forces or weight about any reference axis is equal to moment of the resultant about the same axis. You write here. Algebraic sum of moments of all the part by part weight of all the forces or weights considered individually about any reference axis is equal to moment of the resultant or total weight W about the same axis. You write here. Therefore, you get, take clockwise positive, anything. See, moment about this one. W1 into x1. W1 into x1 plus W2 into x2 plus W3 into x3, etc. Ending term is Wn into xn equal to total weight W into x bar. Therefore, what you get is, I write somewhere here now. And also note, your W is what? W is W1 plus W2, etc. up to Wn. Therefore, this I will remove now. Anyway, I know it. You will substitute later. Important now. Therefore, your x bar in this direction, how you considered x in this direction, equal to W1x1 plus W2x2 plus W3x3, etc. up to Wnxn, that one, divided by, see, you can write here, W1, see, total W is W1 plus W2 plus W3, etc. up to Wn, and remember, this is nothing but W. Or I can tell x bar equal to sigma of W1x1. When you put sigma W1x1, it means W1x1, W2x2, W3x, etc. divided by sigma of W1. Or you can tell sigma W1, see, W1 plus W2x W1 is W. Or you can tell x bar equal to, or simple language, x bar equal to sigma W1x1 divided by W, total weight. Either you can use this one, some people like this one, they want W1x1, W2x2, W3x, etc. divided by W1 plus W2 plus W3. Some people who think a little better way, they will tell W1x1 plus W2x2, etc. divided by total weight W. This is to locate CG. This is to locate CG. Locate CG or horizontal distance of CG. Sufficient. Now I am going to change over to lamina. That's all. Now tell me goodbye. Now see. Now goodbye to center of gravity. Now we will go to centroid. Center of gravity is for 3-dimensional, where weight considered. Here for 2-dimensional, where area considered. And one more thing, we call for when weight, entire body is considered, it is a technically center of gravity. When only plain lamina considered, the projections, where a centroid is there, if you consider a lamina here, it's a projection. In the lamina where it lies, this distance you are not bothered. That is called centroid. But so many people, what they do is actually centroid. But sometimes people use the word center of gravity. I also use it. Sometimes people will tell, sir, in the class, sir, you told whenever weight considered center of gravity, but whenever area considered or lamina considered, you told centroid. Okay, I know it, but center of gravity is more appealing than centroid. But technically centroid. So once in a while, just for fun, I will tell, the question will be given, locate CG. Locate CG, when a lamina given, it is not center of gravity, it is centroid. Okay, now, goodbye. I'll go to fresh page now. Very powerful, the most important part of centroid and moment of inertia. Now, seriously go through. Consider a lamina. Lamina means plain area. You write it. As shown, of area equal to A. See, total area, irregular shape, any random shape, area equal to A. Let T be the thickness, uniform throughout, that is this way, constant. Let G be centroid. See, inside the body there will be center of gravity. Its projection here in the lamina or in this area is G. See, if you consider, make a note here, if weight considered, it is G means center of gravity. Center of gravity. And if only area considered, provided thickness is uniform, then G means centroid. So, okay, now once you imagine G center of gravity and also centroid, that G is centroid or even C center of gravity or even center of gravity, both are okay. But if it's center of gravity, it is inside. Okay, now let's see. I want this distance from any reference line. So, reference vertical line AB. Let centroid G be at x bar. See, x bar. See, that means our x you are measuring this way, our y we are measuring this way. Later I will tell you, some people what they do is they tell reference OXY. That all I will tell it later for you. First to understand. Okay. Let x bar. Bar means, to give important, x bar be horizontal distance of C centroid from a reference vertical axis, say AB. And same way, let y bar be vertical distance of centroid from a reference horizontal axis, say CD, as shown. Okay, this much over. I am removing this one now because space problem is there. This much you correctly understand. You should first write this much. Okay, now see what to do. What I told little earlier counts now. You remember that also. You should write everything systematically, then only it will be clear. Not half of studying. Half of studying, nothing can be achieved. Okay, now, since it is little, weather is cold, to dry, it will take some time. If it is a summer, by this time, it will be fully dry. Okay, now see. First, consider weight. That is, we are considering center of gravity. See, because of the wetness, it is happening. Okay, 1 minute. Because it is wet little, that's why it is, ink is spreading there. Okay, I'll use a rough cloth. Okay, now okay. See, first, consider weight. That is, we are concerned about center of gravity. Only for few minutes, center of gravity. Right here. Divide the lamina into what? Multiple number of parts. Say 1, 2, 3, etc. up to n. See, first I am considering x bar. See, reference vertical line. AB. I told AB. This is reference vertical axis. In here. See, your lamina is here. Divide into parts. 1, 2, 3, sufficient, etc. up to here. N. 1, 2, any number, 3 and n. See here. Now, this area is A1, I write here for 1. This already I told just now, so you should write once again. For 1 area equal to A1, for 2 area equal to A2, for 3 area equal to A3, for n area is An, entire area is A, everywhere T is the thickness I told. Everywhere T is the thickness. So this weight will act here. W1. Somewhere, we don't know where. Okay. W2 through its centroid. W2, W3, etc. up to Wn. And then entire body weight is acting here. G, total weight is acting here. W acting at x bar from here. X bar, the right side. And here W1 is at x1. Already I told just now. B, okay, B. W2 is at x2. W3 is at x3. This already I told you. All to right side, see. And Wn is at xn. Xn. Then we know that x bar equal to, see, x bar, just now I told, equal to A1 x1 plus A2 x2 plus A3 x3, sorry, not A1, here you, W1, first W1, okay, W1 x1 plus W2 x2 plus W3 x3, etc. up to Wn xn divided by total weight W. This I told. Or W1 plus W2, etc. Now, substitute. W1 equal to A1 into T is the volume into weight density. I already told you. Let W be weight density. Let W be weight density. This already told. Volume, this already explained. A1 into T is the area, into thickness is the volume, into W, plus A2 into T into W. This is W1, W1 into X1 plus A2T is the volume, A2T volume into W is the weight into X2, space is not there, plus A3, this is a formula for X bar, A3 into T into W, I put single bracket, into W into X3, etc. up to An into T into W into Xn divided by total weight is A into thickness into W. A into thickness is the volume into W. Now see here. T, 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 T cancels. W, 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 W cancels. Or you get, see, X, I should write X bar here. See, this is X bar. Or your X bar equal to, now suddenly from weight it will change over to area. The formula is A1 x1 plus A2 x2 plus A3 x3, etc. up to An xn divided by total area A, expression for area. Over. Total area A, remember, total area A is A1 plus A2 plus A3, etc., etc., up to An. Some people remember A1 x1, A2 x2, A3 x3, A4 x4, etc., etc., divided by A1 plus A2 plus A3 plus A4 or total area A. This will give you X bar. Now remember, now there is no weight, only area. See here, only area. Therefore, now X bar will give, now only area, therefore, okay, 1 minute. Now your G will become centroid. Centroid and G will become centroid and X bar will give you horizontal distance of centroid from reference axis AB. Okay. Now do one thing. Just to understand, wait, I'll do one thing now. If you want, you can write. Consider once again the lamina. Divide into different parts this way, etc. here. See, A1, part 1, part 2, part 3, part N, then area is A1, area is A2, area is A3, area is AN, full area is A, and centroid is here. Centroid. Now do one thing. Draw a reference horizontal line. This is reference horizontal axis. From here, we will consider y this way. Let centroid be at y bar from here. Now, for A1, space not there, I'll write here now. For A1, see, this distance for A1, its own centroid. This is Y1. For figure 2, it is Y2. Figure 3, it is Y3. Figure N, it is Yn. For entire area, it is Y bar. Then you write Y bar equal to, this is not required, start from here. Y bar equal to directly Y bar from, how Y bar? This way. See, we are taken Y this way, from reference axis, I will call CD, some name, CD from reference axis. CD equal to, same formula, A1Y1 plus A2Y2, etc. up to ANYN divided by total area A. This is the answer, where total area A is A1 plus A2 plus A3, etc. up to AN. This will give you horizontal distance and vertical distance of centroid from to one vertical reference axis. You got horizontal distance from one horizontal reference axis. We got vertical distance. Remember, in what way you consider x, same direction you will get x bar. In what direction you consider y, same direction. See, you consider x. Last time I told you, you considered x this way. So your x bar also will come same way. Now you consider y this way, so y bar also will come same direction. Now this is for, I'll tell you, see, this what I told, I'll rub the board and then I'll explain. See, now very important. This all summary you are right. Now, therefore, if the given lamina can be divided into multiple number of parts, where we know centroid for each part, or multiple number of parts, or you can tell definite number of parts. Then use the theory x bar equal to a1x1, actually basic formula is what? Basic formula is sigma of a1x1 divided by total area. Why? See, because sigma a1x1 means a1x1 plus a2x2 etc. and y bar equal to sigma of a1y1 by total area. That means equal to a1x1 plus a2x2 plus etc. Okay, a3x3, let it be there. 3 are there. a3x3 etc. up to anxn divided by total area A, that is a1 plus a2 plus a3 etc. up to an, and y bar equal to a1y1 plus a2y2 plus a3y3 etc. up to an divided by total area, that is a1 plus a2 plus a3 etc. up to n. In the end, I am giving summary for you. That is the most important. This is when you can divide into definite number of parts. Example, suppose imagine a section given like this. This will be my first example. A section given like this. Some people call it L section or angle section like that. Here, see, you can divide it into two parts. You will get two rectangles. You will be knowing later that for rectangle, centroid lies here. So, you can use this way. Or, for example, suppose any section, I section given, see here, this way. This way, I section given. What you can do is, you can divide into three parts and apply here. Or, suppose you are given a shape like this. See, for example, this way. Okay, then you can divide into a triangle. See here, one more triangle, say maybe one more triangle here and a rectangle. Because later you will be knowing expression for locating centroid for rectangle, triangle, semicircle, quadrant of a circle, circle also is there, circle etc. So when you can divide the given lamina into different number, multiple number of parts or a definite number of parts, where for each part, if you know the centroid, then you can use this formula. Now, but I'll rub the board now, I'll clean the board also, but see. But if the given lamina cannot be divided into definite number of parts, why I will tell you later, then use principle of integration. That is, see here, consider a lamina as shown, total area A, capital A. Let you write here, let G be centroid. Let G be centroid. At what distance? X bar, remember our X is like this. You can take way, whatever way, X bar from, right, X bar from a reference vertical line AB or at Y bar from this way, see, Y bar from a reference axis CD. Then what to do? I will give final summary, that is the most important. Then consider, see, now, then to get X bar, see, consider elemental area, say DA. This is D. See, later when you go to rectangle, you get B by D. This is the depth D. This is D, mathematical D. Remember, This D is mathematics, integration, calculus at consider area dA at x from AB. X from AB. See. This is your reference axis AB. Everything I will make clear. You take elemental area, very, very small area. See, elemental area means very, 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 very small area dA. Now no x1, x2, x from here. Now, there are infinite number of dAs. Therefore, now your x bar equal to, see here, now your x bar equal to x bar from AB. X bar from AB. See, your x is this way. This x bar from AB equal to this dA into this x plus one more dA into that x, one more dA into that x, one more dA into that x, or it is sigma of dA into x. When you tell sigma of dA into x, it means one elemental area into that x distance, one more elemental area into that x distance, another elemental area into that x distance, never ending. Sigma dAx divided by A. A equal to sigma dA. Sigma dA, or x bar is also equal to, remember, sigma means integration. You should know it. It is integration of dA into x divided by total area, that is integration of A, only dA. Integration of only dA. See, numerator is integration of dA into x. Denominator is integration of, see, A1, x1, A2, x2 by area divided by total area, or integration of dA. Now do one thing. Once again right now, to get y bar, consider elemental area dA at y from CD. Y from CD. Okay, now do one thing. Take reference axis CD here. CD. This you remove it. Okay, CD. This way we measure y. Then elemental area dA, see, at y from here. Y from here. Then your y bar equal to y bar from CD. Y bar from CD equal to sigma of dA into y divided by total area, that is sigma of dA. This is summation, or you can tell y bar equal to integration of dA into y divided by area, that is integration of dA. This is formula for x bar, formula for y bar. Now, one more note I will tell you. When you, here I told elemental area, but remember here principal point of view elemental area. See, one very important now, I will tell you here now. See, for principal we write elemental area. For principal purpose, we write elemental means very, 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 very small. Elemental area dA. Now dA. But later area dA, which we consider to be something like this. No, but later we consider elemental strip. Once again remember, of area dA only, area dA, and thickness means not this perpendicular thickness, in the strip thickness, and thickness dx for x bar, thickness dx for x bar, or thickness dy for y bar. See, but very important, It should be elemental. See, dx is elemental, dA is elemental. So both are elemental. So therefore you take dx, you take strip, not dot, not a point. Point you can't take, you take a strip. That is CL. I'll show you now how we take it. That is, if x bar required, then see here, reference vertical line, you take a strip, very small strip of thickness dx and area dA. Area equal to dA, strip at x from here. This way we take. And for y bar, CD reference line, okay, I'll take dx here, thickness dx. You take a strip, see, not this way, take a strip here, and thickness equal to dy at y from here, and area equal to dA, once again, area equal to dA. Okay, now this all I will explain when the time comes. So now I am going to give you final summary, most important, final summary that you repeatedly go through till you get perfection. Go through. I will write the full page because time consuming. Very in detail I have to write. So I will make a neat note in the board and then I will start. That is, I will pause the recording for some time. Now, concluding part of the basic concept. Final summary. See, make a note. These all thoroughly study. If the given lamina can be divided into finite number of parts, finite means definite number of parts or known number of parts. You write here, known number of parts. For example, 2 part, 3 part, 4 parts, say 1, 2, 3, etc., where we know how to get the area of each part, that is A1, A2, A3, etc. And also we know how to locate centroid for each part. You should know. So therefore, the definite part you are considering should be a standard part, right? Rectangle, triangle, semicircle, because we will have formula for that one, or circle, quadrant of a circle, etc., etc. Because for, see, later we will derive expression for locating centroid for rectangle. So once you derive it, you know it. Rectangle, triangle, or what? Circle, semicircle, quadrant of a circle, etc. So you can write one more note here. If the given lamina can be divided into multiple number of parts, known number of parts, say some rectangles, some triangles, and then some circle, semicircle, or quadrant of circle, because for all of them you will be knowing how to get area and also how to locate its own CG. Then horizontal distance of centroid from any, see, horizontal distance of centroid x bar from any vertical reference axis is sigma a1 x1 by a1, that is a1 x1, a2 x2, a3 x3, etc., etc., divided by a is a1 plus a2 plus a3. Now, and vertical distance of centroid from any horizontal, see, vertical distance of centroid from any reference horizontal axis is same way a1 y1 by a, etc., etc., you write here. Now, one very, very important, x1, x2, x3, distances of components, x bar for entire area. Same way, I told in the class I am telling you something now. You should write it. See, for these two, I am giving important now. You should make a firm note somewhere outside. Very, very important. When you consider x1, x2, x3, etc. from the reference axis, you decide how you decide. See, you can take x1 to right side or left side. Usually you take right side. Then x bar also you will get in the same direction. If you consider x1, x2, x3 all to right side, x bar also you will get to right side. Whereas if you take x1, x2, x3, etc. to left side, x bar also we will get to left side. Very, very important. Same way here. y1, y2, y3. What direction from reference axis you consider component-wide centroid? How y1 area there is no sign. y1, y2, y3. Your y bar also will come in the same direction. Suppose you take y1, y2, y3 all above, y bar also is above. Or if you take y1, y2, y3 below, y bar also will come below the reference axis. This is the most important. Write what all I told now, make the note. Later I will do a master question where this sign convention will be cleared next class. Okay, this is when you can divide into definite number of parts. Now, final summary continued. See, lastly, closing part over. Next class will be problems. Now, final summary continued. You should continue. Summary continued. When given lamina cannot be divided into definite number of parts or known number of parts. Known number of parts, you should write here, where we know how to find the area and how to locate centroid of each part. When it is not possible, then go for principle of integration. That is, I will tell you what to do now. I want a full board now. What to do. See correctly what to do. Closing part. Integration. To get x bar, I will first finish x bar. That is right here. Horizontal distance of centroid. I already told you. X bar from any reference vertical axis. See it. Right now I will tell AB. Say AB. What to do is, see, if you want x bar here, you take a strip here. Small strip. Consider elemental strip of thickness dx. Dx means what? Very, 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 very small. Okay, I should write here. Space. 1 minute. Camera. Sometime I give too much above the line. May not come in camera. Oh, coming. No problem. Thickness dx. Remember, see, now thickness should be dx. Very important. Dx at x from here. See, at x from here. This is the way x. At x from here, thickness is dx. See, this is the strip. And the strip area equal to dA. Elemental area dA. Then x bar in the same direction as x. If you take x this way, x bar also will come this way, equal to, no sigma now, integration of, see, a1, x1, a2, x2, no a1, dA into x over. Means what? dA1 into x1, dA2 into x2, dA3 into x3, etc. In general, dA into x divided by total area, that is nothing but integration of dA over. This is for x bar. Write neatly this one. Now do one thing. Once again write. To get y bar, you should not do this way. You should create one more sketch. To get y bar from any reference horizontal axis. I told you 1000 times. If you want vertical distance, reference axis should be horizontal. From any horizontal axis, say CD, some name. CD. See, that will give you x bar from AB. I told earlier, see, earlier I told you AB here. Now, AB. Okay, now take a strip here. See, this way strip now. Not this way. Because the strip should have y constant. See, last time strip should have x constant. Now the strip should have y constant. Elemental strip of thickness dy and area dA. Strip of thickness dy and area dA. Area dA. I forgot to write last time. See, this thickness is dy and this area is dA and distance is from CD. This is y. Y you take this way. Then y bar from y bar, I write here, then y bar from the reference axis CD equal to dA into y divided by area dA. Okay, now y bar will be in the same direction as y. If you take y above, y bar also will come above. Okay, this we are using when I do a problem. Whenever I am, now lastly I will tell you, whenever I can divide into known number of parts, I will go for summation. A1, x1, A2, x2, A3, x3, etc. And for y bar, A1, y1, A2, y2, A3, y3, etc. Whenever I cannot divide into parts, definite number of parts, I go to see integration. X bar is integration of dA into x. Y bar is integration of dA into y. See, integration of dA into x means dA1 into x1, d. That is the meaning of integration. So many people, they don't know what is the real meaning of integration. Okay, this way I will do it over. I will not explain again and again in the class. I will tell. If clarification required, see the final summary of lecture number 2. Lecture number 1, you will get the real feeling of center of gravity and centroid with an experiment. If you remember, see, where is my model? It has gone somewhere. There was a model here using which I explained thoroughly for you the real meaning of centroid. Where it has gone? Here, see. See, if you remember last class, I once suspended here, suspended here, suspended here, suspended here. Finally, I got centroid here. Experimentally explained in lecture number 1. Today, mathematically explained in lecture number 2. Next class onwards, we will do marathon example. Now, no more theory. Marathon examples now. Okay. We will meet in the next class. Thank you.